Hi, welcome to the Colors and Crayons library presentation.
Can you
What you're
hear?
seeing is the Snap color picker,
You cannot. Okay, so Zoom
No,
is.
no, we can
Yes,
hear.
yes, we can, we can.
Someone. Okay, so I thought Brian was shaking his head. Cool.
which you see when you click
I'm
on
not
the
hearing
colored
any
square
sound.
in the Set Pen Color to block.
But we are, Brian.
Colors actually form a three-dimensional space, not because the world has three dimensions, but because human eyes have three kinds of color sensors. It's different for other animals. There are several different choices, though, of what axes to use in color space. Most programmers are familiar with red, green, blue color space, for example. But this color picker is based on the HSL color space. The horizontal axis is hue, which more or less means where the color is in the rainbow, except for magenta, which isn't in the rainbow at all. The vertical axis is lightness, which ranges from pure black at 0 through dark shades of the color to the pure rainbow color at 50, then lighter tints of the color to pure white at 100. Users find these two dimensions obvious without explanation. Since your screen has only two dimensions, the color picker doesn't include the third axis, saturation. This is 0 for gray through dullish tones of the color to the pure color at 100. Picking saturation to leave out of the 2D picker was an obvious choice, since users generally are more interested in bright colors than in dull ones. Unfortunately, HSL is not the color space used by the primitive pen color blocks. Instead, they use HSV. In this strange color space, hue is the same as in HSL. Instead of lightness, though, it has an axis imaginatively called value. In Snap, we call it brightness. Provided that saturation is 100, a value of 0 is black, and a value of 100 is full color. Essentially, it's the bottom half of the HSL color picker. HSV has an axis called saturation, but unfortunately it isn't the same as HSL's saturation. Provided that value is set to 100, the saturation scale runs from pure white at 0 to pure color at 100. If neither saturation nor value is 100, you get grays and grayish tones. Why does Snap use this terrible color space? The simplest answer is that we inherited that decision from scratch. Another answer is that JavaScript, the language in which Snap is implemented, provides HSV as its native color space. So the first goal of the Colors and Crayons library is to undo that decision. The next problem with native colors has to do with hues. This problem wasn't caused by programmers, but by evolution, which made us recognize a wide range of colors as green. By contrast, the yellow band is much smaller, and the orange band is a mere sliver. Wouldn't it be better to have a fairer distribution of hues? This is the fair hue scale. In addition to equalizing the widths of the color families, it promotes brown to a real color. You're meant to think of brown as just a dark orange, but we humans give it its own family name, and most shades of brown don't look orange at all. The third problem is that although navigating through color space can be fun if you don't care exactly what color you end up with, often you do want a particular color. Colors have names, and you'd like to be able to choose a color by its name. These are examples from a metaphoric 100-crayon box, in which every color has a name. Note that one of the names here is Looks, the color of the Snap Looks blocks. All 10 block colors are named crayons. But sometimes you want a continuous gradation of colors rather than distinct colors, but you don't want to have to think in 3 dimensions. If you only want fully saturated colors, you can use the fair hue scale, but maybe you also want some darker shades. For this, we provide the one-dimensional color number scale, which includes the complete grayscale, the spectral colors, and darker versions of the spectral families. Including grayscale in the color numbers also solves the old black hole problem, in which you somehow make the pen black and then try to get other colors by saying what used to be called change pen color by 5. It's not quite so confusing since we changed the name from color to hue, but that still doesn't help you get a continuous range of colors that includes both black and the rainbow colors. Okay, those are the problems we're solving. Now, here's what the library itself looks like. The 3 blocks in the top left are direct replacements for the 3 primitive set pen, change pen, and pen blocks, but with a greater variety of options. The 4 blocks in the top right provide a new feature, first-class colors. These blocks report a color. It's actually implemented as a 1-pixel costume of that color. Strictly speaking, we no longer need the pen-specific blocks because we can get their effect by composition of the first-class color blocks. But it turns out that the library can do a better job with the change pen block if it remembers what axes you used to set the pen color in the first place. Here are the options for what attributes of a color you can set. Color means the color itself, the output from one of the first-class color blocks. Color number, crayon, and fair hue are the 3 one-dimensional color scales you've already seen. The X11 window system provides a set of several hundred color names, also adopted for the web by the World Wide Web Consortium, and we accept those names too. Finally, there are 5 3-dimensional color spaces. Let's start at the bottom with RGB. For each of these spaces, you can set an individual value, the red or the green or the blue, or you can give us a list of 3 numbers, or if you want RGBA, the 4th number that sets the alpha channel, which has to do with transparency. Or you can give us a hexadecimal numeral that you found on the web someplace for the color you want. Here's HSV, the traditional snap block color space. You can set hue, saturation, value, or again, a list of 3 numbers. HSL is the same thing, hue, saturation, and lightness. And then there's fair HSV and fair HSL, which are the same as HSV and HSL, but using the fair hue scale. The pull-down menu in the second input slot depends on your choice in the first input slot. Here's the menu for crayons. The 100 crayons are divided into 10 families, so if you're looking for sepia, you know that's a kind of brown. So you look in the browns and you find sepia, number 33, and that's what you get. Also, instead of using the menu, you can type the crayon's name directly into the second input slot. So I can say denim, for example, and we get blue jean color. Color numbers and hues are continuous, not discrete, so we can't give a complete menu of them, but we do provide the landmarks. For color numbers, you get the official spectral version of each color and the darkest color in the color number scale from that family. Since the menu shows you the numbers, if you want, let's say, a yellow that's darker than spectral yellow, but not the darkest possible yellow, you might just type in 52 using the menu as a mnemonic aid. And there's color number 52, which is a somewhat dark mustardy yellow. Similarly, the menu for fair hue numbers just gives the values for the official spectral version of each color family. The vector options accept a list as a single input or 3 separate numeric inputs. So if I say, let me pull this out. If I say set pen, I don't know, RGB vector, I can drag in a list of let's say 255, 128, 0, which gives me a official spectral orange. Or, using the variaticness of these inputs, I can say, oh, I don't know, 0, 255, 255, and that gives me cyan. The last 2 library blocks are for color mixing. This is a feature that forum participants wanted very emphatically. I'm not going to say more about it because color mixing turns out to be enormously complicated. Read the manual. Finally, a few words about remaining problems in the library. One of them is it's very slow. Someone posted a project on the forum that showed a gradient of colors from black to red using the brightness setting in the primitive set pen block. I asked, why don't you use the library? And got the response, it's too slow. At the time, it was even worse than this, taking 2 full seconds to generate the gradient. But it's still a factor of about 40 slower than the primitive blocks. I'm going to try to fix that by smarter programming, but may end up having to rewrite the library in JavaScript. Also, both HSL and HSV are oversimplified color spaces, in particular with respect to brightness or lightness. They assume that all spectral colors are equally bright. But if you're like most people, you see spectral yellow as much brighter than spectral blue. I'd like to incorporate some of the more realistic color spaces into the library. Thanks for listening. Okay, there we go. Questions? Oh, thank you.
I missed the definition of spectral.
Oh, the rainbow colors, spectral as in spectrum.
Like red, orange, yellow, green, blue,
Yeah.
indigo, violet.
Yeah.
The Roy Biv thing. I see.
Yep.
Is the fear hue scale an invention of you, or is this a semi-standard thing?
Me. This is all me. I'm a big fan of orange and brown, so I always have trouble finding them in the regular hue scale.
The RGB optionally has the alpha, but you don't add alpha to any of the others. Why is
Right.
that?
You can put the an extra number because of that variadic input. You can give, oh, thank you, Natalie. You can put a transparency number as well as whatever else you're setting in the input. So yeah, that works. So, okay, anything else? Great, we're a minute over.